Okay, good afternoon.
Hey, how's it going?
Good. Okay, so do you guys see I post the section lecture notes of today in the Canvas already? So today we're learning section 6A. Do you guys see the lecture notes? Yes or
Yeah.
no? Give me some response.
Yeah.
Okay, thank you. I just realized that this is already the 10th week of this semester. So the whole semester should have like 15 weeks, right? Including the fall break. And we are already at the end of the 10th week. So we're 3/3 done with this semester. How fast? How do you guys feel?
Let's go.
That's what I'm saying.
You feel slow?
He said, let's go.
Okay. So let me turn on my document camera. So this is section 6A we're going to learn today. But before we learn this section, I want to play a YouTube video to you guys to show what is unimodal, what is single, what is double, a bimodal. So we're learning something pretty new. We're learning statistics. 6A, this section is about characterizing data. So maybe you have heard of the word data. Something is very abstract. So data is just a bunch of numbers recording some information. Okay. So you can imagine this as a distribution of people's heights. So if there are two peaks of this height, this might be due to we have two genders. On average, males are taller than females. This is one of the possibility, okay? So let's go watch the YouTube video. So this YouTube video is approximately 4 minutes and 30 seconds.
Hi, welcome to Fun Math. Today we will talk about types of mode. In the previous video, we talked about what is mode and how to find it. Now to quickly review, what is the mode? So what is the mode? The mode is the value that appears most often in the data set. There are 4 types of mode: no mode, unimodal, bimodal, and trimodal. Let's first begin with no mode. Here we have a data set. In it, we have numbers 1, 2, 3, 4, 6, 8, and 9. Here we have a frequency table. Here you can see that all the numbers appear only once in this data set. That is why there is no mode in this data set. Now let's move on and talk about unimodal. Here we have a data set. In the data set, we have numbers 1, 2, 3, 6, 7, and 8. Here we have a frequency table. 3 has occurred twice, and all the other numbers have appeared only once. So what is the mode here? The mode is 3 because 3 is the value that appears most often in the data set. That is why this data set has one mode, and that is 3. Since this data set has one mode, it is called unimodal. Let's move on and talk about bimodal. Here we have a data set. In the data set, we have numbers 1, 1, 2, 4, 4, 5, and 6. Here we have a frequency table. If you see, 1 and 4 have appeared twice, and all the other numbers have appeared once. So what is the mode here? It is 1 and 4, because those two numbers have appeared most often in this data set. And that is why this data set has two modes, and those are 1 and 4. Since this data set has two modes, it is called bimodal. Now let's move on and talk about trimodal. Here we have a data set. In the data set, we have numbers 1, 1, 2, 3, 3, 5, and 5. Here we have a frequency table. 1, 3, and 5 have appeared twice in the table, and 2 has appeared only once. So what is the mode here? The mode is 1, 3, and 5 because those are the three numbers that appear most often in this data set. That is why this data set has 3 modes, and those are 1, 3, and 5. Since we have 3 modes, we call this trimodal. There's something to remember here. If your data set has more than one mode, it is called multimodal. All right, let's review what we learned today. We briefly talked about what is mode, and we saw different types of mode: no mode, unimodal, bimodal, and trimodal. In no mode, there was no mode at all. In unimodal, we had one mode. In bimodal, we had 2 modes. And in trimodal, we had 3 modes. If a data set has more than one mode, it is called multimodal. All right, I hope you learned a lot from this video. Please like and share it and subscribe.
Okay, we finished watching that video, so let's come back to the lecture notes. So after you connect those data, you can put them into a graph so that it can gather some information by just looking at them. The first idea we're going to encounter is the distribution. The distribution of a variable refers to the way that its value is spread over all possible values. This is something that's very abstract. So how should we understand it? Look at the graph here. Okay, so imagine this is all the students' heights in our class. Just imagine this is all the students' heights. So on the X arrow should be height. Somebody maybe here is 5 feet. Maybe here is 5 feet and 2 inches, 4 inches, 6 inches, 8 inches, 10 inches, 12 inches, 6 feet. So those are my marked lines. So you can imagine that for each of the small segment here, we have some people fall into this category, right? So for example, I'm 5'5", so I fall in between the 5 feet 4 inch and 6 inches. So I'm here. So at least one person I is in this bar. Maybe somebody else is also in the same height with me. Maybe Tom is also in this bar, is also 5'5" or 5'4", or Jack is also 5'4". Maybe we have 3 people here. So the height of those bars represent how many people fall into this subcategory. Okay, so I'm trying to explain what does this histogram mean. The height represents how many people fall into this category. The bottom, also the x-axis, represent what does this category mean. In this case, I would just say it means height, how tall a person is. And the y-axis just means how many people belong to this height group. So if we were just talking about height, we may get something like this. So my x values are not well selected. So I think on average, people's height are between somewhere 5 feet 8 inches or 5 feet 10 inches. So I should have put it for 8 or 10 inches here. But you get the idea. So on average, so most people should fall into this category. Okay, since we have most people fall into it, the height of this bar corresponding to the y value has the highest value. However, not every thing has just one bell shape. Sometimes we have 2 bell shape. As I mentioned at the beginning of the class, so we have 2 genders, at least 2 genders. So for simplicity, we just consider we have 2 genders. We have males, obviously, they are taller than females. So one bell is for male. I mean, some female may fall into this category, but dominantly taller people are males. And the other bell can be for female. So this is just graphic understanding. There's nothing, no calculation here. I'm just explaining why those shapes may make sense. Okay, so does anyone has any question about these 2 graphs? Okay, do not be shy. If you have any concern, any question, feel free to ask. Okay, so the first 2 are distributions. The third one is also a kind of distribution. However, it is not represented like in here using bars. It's more weakening curve, but it's also a kind of distribution. Those are just different ways to represent distribution. Okay, so here comes our first example. So determine whether the following scenarios would represent distributions that are unimodal or bimodal. So after watch the short video made by that little girl and her parents, I assume her parents are assisting her making the video. So do you guys remember what is unimodal, what is bimodal? Okay, so unimodal just, there's one value appears most often when you connect the data. Bimodal is, we have 2 values appears most often. So the idea is just simple. So how about the question A? The distribution representing the weights of all high school basketball players at a school. So is this, when you connect the data, you will see a unimodal or bimodal. Okay, I need somebody to voice. Blake, it seems that you are trying to say something. Yeah?
Is it bimodal?
Yes, so why do you think that?
Because it's weights of all the high school basketball players,
Yeah,
all. So like all of them being plural.
okay, so why would you think it is bimodal?
Isn't unimodal single or like singular?
Okay, I got your point. So let me elaborate your point a little bit. Thank you for sharing. So in a school, imagine those basketball players. They can be males and can be females, right? So again, on average, males have a larger size than females. This is just common sense. If you want to argue with this observation, there's always some counterexamples. However, we're just using the common sense to discuss the situation which is the most frequently encountered. That is, males have larger size than females. So when we have high school basketball players, we have boy, we also have a girl. So if you draw the graph, what would you see? You would see something very similar with this, right? You would see we have the two bells. One bell is dominantly female, the other bell is dominantly males. So I claim this is bimodal. But you may question me. You say, wait, in the video, the bimodal is not described in such a way. Do you guys know there's a subtle difference between the definition on our lecture notes and the definition, our description here? So in that short video, we have a few small, the little girl gave us a table of some small numbers, right? 1, 2, 2, 3, blah, blah, blah issues. So that video actually give a different idea of bimodal. She described that the two numbers which appears most frequently, they become a bimodal. But in our lecture notes, bimodal just means you have double peaked shaped distribution. Okay. So there's a subtle difference here. So when you work on your homework or when you do anything related with this class, please follow this idea. Bimodal is just double peaked. Okay, so sometimes the height may be different. So in that small short video, the little girl showed that those two most frequently encountered values, they have exactly the same number of each. So in our class, we do not need to be so strict as long as they are two most frequently, there's some kind of double peaked shape appears in the distribution. We call it bimodal. Okay. So any question about why this is bimodal? Okay, so the next question, the distribution representing the amount of time students in Math 1010 spend studying for the exams. So on Tuesday, you just did your exam. So how about this? Instead of me telling you the answer right now, let's do a short survey. Since you just did the exam 2 days ago, so type in the chat session, round to the nearest hour, how many hours you studied for the previous exam. Please type in the chat session, just in terms of hours. So everybody type in how many hours. After we do the short survey, we will use your result to illustrate this question. Okay, so has anybody not done that yet? So let's look at the result. Everybody look at the result. So we have some people study for 1 hour, right? We have 2 people study for 1 hour. We can make a small graph. This is how number of people. This is how many hours they study. We have 2 people study just for 1 hour. We have 1, 2, 3. We have 3 people studying for 2 hours, right? How many people we study for 3 hours? Okay, we have, so if I counted it correctly, we only have 1 person study for 3 hours. How many people study for 4 hours? Beginning with 4. Correct me if I made any mistake. How many people study for 5 hours? Nobody. I didn't see 5. 6 hours. 1 people 6 hours, 1 people 7 hours, right? Okay. So once we make a table like this, I know my table does not look nice. However, it's pretty sufficient. You can see if we convert this into a graph like this, do we have a single peak or double peak? Anyone can voice their opinion. Okay, anybody want to voice his opinion or her opinion?
Double peak.
Why would you think so?
Because hours 1 and 2 have like the most people compared to the rest of the hours spent.
Okay, so let me draw the graph. You will see whether we have 1 single peak or double peak. Thank you for sharing. So there's somebody studies for 0 hours, somebody study 1 hour, somebody study 2 hours, somebody studies 3 hours.
Hey, it's got to be single or just a single because of the 1, because the 1's the most.
Yeah, you're right, but let me finish this graph. Somebody study for 7 hours. So the first hour, we only have 2 people. So let's say 2 is here. So somebody who studied 2 hours, we have 3 people. 3 is here. So the first graph looks like this. Then 2 hour looks like this. Then one person study 3 hours. One person study for 4 hours. Nobody study for 5 hours. Somebody study for 6 hours. Somebody study for 7 hours. Okay, so you guys see the distribution, right? You have a single peak here. So let me repeat, the y-axis represents how many people fall into this subgroup. The x value represent how many hours people spend on studying. So if you look at this graph, we just have one peak here. Okay, so this is single peaked or unimodal. Okay, so this is for question B, and we illustrate it using this graph. Again, those questions are the verbal questions. Different people may have different opinions. So we will see that question C is more controversial. So the question C asks us the distribution representing how much students spending on parking over the course of a semester. Okay, so again, we can do a survey. But before we do the survey, anybody want to voice his or her opinion, whether this is unimodal, bimodal, or other cases?
Unimodal, because it stays the same.
Yeah. So to save time, we do not need to do the survey right now, but I would expect something like this happened. There's some people, most people come to school occasionally, but there's really some people who come to school constantly. Then they belong to this right end. So the x value is how much people spent in parking. So the y here is just number of people. Okay, so for me, I come to school twice a week. Maybe I kind of here. I'm not sure about you. I'm somewhere around here. I'm pretty sure some students in our class come to school maybe 4 days a week, 5 days a week, or it's even on over the weekends. So that person definitely spend much more money on parking. Okay. So does anyone has any question? Oh yeah, I forgot to say that there's somebody who never come to school. Do you guys remember at the beginning of class, we had somebody living in Alaska? Do you guys remember that girl? She was living in Alaska. Oh yeah, just somebody at the beginning of class, she mentioned in the introduction part, she's living in Alaska. So she almost never come to school and never spend money on parking. But if she would come to school, she had to spend a lot of money on air ticket. Okay, so once we finish the previous page, we're going to encounter another concept. Previously, we talked how many peaks our distribution may have, right? Once we discussed about the peak, number of peaks, we're going to talk about variation. Variation describes how widely the data values are spread out. So we have 3 graphs. The first one, all the values are very centered around here, right? The second one is a little bit more spread. The third one is very, very spread, kind of flat out. So I hope this idea is pretty simple. Okay. So example 2. We compare 2 distributions. One is 20 elite female gymnastics. The second group is 20 randomly selected women. So randomly selected women, it means just ordinary people, can be, can have very different size. So just imagine you go to Queen Supers, the people you encounter are just those 20 randomly selected women. Just imagine those people are in your group. When you think about female gymnastics, just imagine you are still watching the Olympics during the summer. Imagine those people, those girls in the Olympics. All of them are like 16, 18, 20. Look how skinny, how well-shaped those people are. But randomly selected people do not always have that kind of skinny body shape. So would you expect the variation of the weights to be greater for the gymnastics or greater for the randomly selected women? So which one has more variation? Okay, I would like to listen to your opinion. Can I call somebody's name in this class? I seldom hear from some of you. So I just want to have a try to call some of them to hear from your opinion. Okay. Hello, Yash. Yash, are you there?
Yes.
Yes. What is your opinion on this one?
I think that if like for the variation for the weights, for the gymnasts wouldn't be as great than for like randomly selected women.
Great, thank you. So does anyone has some different opinion? Okay, so I strongly agree with Yash. So the gymnastic definitely has much smaller variation. In weights. Okay. Ordinary people, I mean ordinary women. That's it. So once you get the idea, that's it. So today's class, we are not doing any calculation. Everything we do is very easy. Just read the question, understanding the idea, then done. So that's the second concept we learn about distribution. The third concept is about symmetry. So sometimes when you draw the distribution of something, you may see a pattern of symmetry. So look at the 3 graphs here. All of them share one similarity with each other. They're all symmetric. So once you draw a line in the middle, the left part is identical with the right part, almost identical. So this is the third idea about distribution. Then we have example 3. Label the following distribution as either symmetric or non-symmetric. Also label the number of peaks in the distribution we would have. Huh. The first one is talking about ice cream sales. The second one is salaries of NBA players. So you can think about it, but I would like to show you like a YouTube video discussing NBA players so that you have a better idea how the distribution would like. Okay, so are you ready? We're here for a second video in today's class. This is about NBA players. After watching this video, you will have a better idea how the distribution would like. Okay, so this is a 14 minutes video. We're not going to watch every second of this video, but after watching the first 7 or 8 minutes of the video, you will have an understanding of how the distribution would like. Okay, ready? Play.
Make? Well, the answer is easy, right? You just pick a player, take their annual salary, divide it by the hours played, and boom, we got their hourly rate, right? Well, it's a bit more complicated than that. NBA players aren't born overnight, and like any virtuoso, the crafting and molding of the body and skill necessary to make it to the highest level of play takes years and years. And these years and years of blood, sweat, and tears often go uncompensated. There's a generally accepted rule by researchers that says it takes 10,000 hours of deliberate practice to master a skill, whether it's playing a guitar, busting out a dance, or breaking a defender's ankle to then hit him up with a pull-up jumper from behind the three-point arc. When I say deliberate practice, I'm not talking about casually hitting up the court with your girls to practice half-court shots. I'm talking about pushing your game to the limits, seeing if you can beat your numbers from the previous week, and practicing drills you've never done before. If we assume it takes 10,000 hours of practice to have the skill necessary to make it to the NBA, and we practice 2.5 hours a day, every day starting at age 7, by the time we turn 18 years old, we would have practiced roughly 10,000 hours. Now hold up, I want to tell you more, but at this point you might be wondering, Nick, what does any of this have to do with how much an NBA player makes? Well, here's the thing. When calculating an NBA player's hourly wage, we can't forget all the unpaid, behind-the-scenes work that goes into forging a player like LeBron James. Now, for this video, I'm not going to focus on LeBron because he's an outlier. His annual income doesn't fall within the normal range of an NBA player. And if we focus on the outliers of any industry, we're of course going to come up with overly inflated numbers. And I get it, he's an easy pick because he makes a loony amount of money, especially with his endorsements, but so do the outliers in any industry, and none of them paint a compelling picture for how much we can expect to make if we become a professional author, dog trainer, or dancer. So the first thing we need to do to find out how much an NBA player really makes is to find out what the average annual salary is for an NBA player. This should be easy, right? We just take the total amount of money the NBA is paying its players, $3,815 million, divided by the total number of players or contracts the NBA has, which is 545, and boom, we got our average of $7 million, right? Well, not exactly. $7 million doesn't really portray what the average player makes because there are too many top-heavy outliers like Steph Curry, James Harden, and Blake Griffin, and too many bottom-heavy outliers like Derek Walton, Sheldon Mack, and Malik Newman. If we're to look at these 6 players, combine their annual incomes and divide by the total number of players to get the income average, we would get $18,748,679.66. Don't ask me where the 66 cents comes from. I'm not good at math. So $18.7 million is our average, which pretty much grossly misrepresents both groups of outliers by over $18 million. So you can see how coming up with a true average is difficult. So what we're going to do is take the exact middle or median salary of all the NBA players, which is about $3 million, combine it with the average salary of $7 million, and then divide it by 2 to give us the true average of the averages of a player's salary. Look, why we're going to do this, I don't really know, and I'm not a statistician, obviously, but for whatever reason, with the lingering mathematical neurons I have remaining, this seems to make some sort of intuitive sense to me. So we'll say the average NBA player makes around $5 million a year. Great. Now we need to divide this number by the amount of time a player spent having done the things he needed to do to make it to the NBA. This is what we might call prolonged job orientation, and we'll assume this is the 10,000 hours we talked about earlier, which mostly consists of practicing basketball. And we need to divide the $5 million by all the activities the player does that are essential to playing in the NBA, including playing in the actual NBA games themselves and the things that happen during non-game time. And really, it doesn't even matter if our average player sits the bench or plays in the game because he's getting paid either way. So when it comes to calculating the true number of hours a player works every season, this is when things get infinitely complex and very individualized depending on the player. We don't know what any player's numbers are when it comes to the true number of working hours. That is, the amount of time spent practicing, time spent traveling to and from games, what their off-season regimen looks like, summer practices, individual workouts, film sessions, interviews, negotiating contracts, and a host of other things I'm intentionally omitting or forgetting. Basically, all that stuff a player isn't directly being compensated for, but is still a requirement of his position. To come up with the true number of working hours, we're going to have to generalize. When we think about all the uncompensated stuff, I think it's fair to assume at a minimum, an NBA player is working 40 hours a week on and off season. We could easily make this number higher, but because we are obsessed with 40-hour work weeks in America anyways, I think it's a good number to use. This means the average player spends 2,080 hours a year working, but we'll be generous and subtract 80 hours to compensate for error or for vacation, or just to simplify things. The average career length of an NBA player is 5 years. This means he will spend 10,000 hours working over the course of his 5-year stay. So let's meet our average player and figure out what his hourly wage actually is. This is James Jordan. And just in case you're wondering, James and Jordan happen to be the most two common NBA player names. He's 6'7", 217 pounds. He spent 10,000 hours growing up practicing basketball without compensation. He played 5 years in the NBA, totaling 10,000 hours of work, and he made $5 million per year, totaling $25 million over 5 years. So we've got all the numbers we need to figure out his hourly wage, and this is how much James Jordan makes per hour. James Jordan made $1,250 per hour. That's about $21 a minute or 35 cents a second or $2.5 million a year. Not too shabby. Imagine somebody sitting next to you counting out loud, and every second they flip you a dime and a quarter. That's the life of a modern day king, right? But had we not calculated his true working hours, had we not added in that arbitrary 10,000 hours of job orientation that happened from age 7 to 18, plus the 10,000 hours of overall working time, he would have made a much greater amount. If we just factor in the game time, the amount of time on the court James Jordan played while the game clock was running, he would have played 82 games a season times 5 seasons, which is 410 games. And every game is 48 minutes. So that's 410 games times 48 minutes, which is 19,680 minutes or 328 hours. So in 5 seasons, his total working time would have been 328 hours. So if we took his total salary after 5 years, which was $25 million, and divided it by 328 hours, we would get a whopping $76,220 per hour. That's insane. But I will also say it's a meaningless calculation because it's like calculating a heart surgeon's hourly wage without considering the time and cost the surgeon spent putting himself through school, plus all the money he could have made in another job while he was earning his education. Like I said earlier, it's easy for us to forget the behind the scenes work that goes into many high paying careers. When most people calculate an NBA player's hourly wage, they like to use the calculation that gives them the biggest number, not because it's an accurate portrayal of the NBA player's true wage, but because it's, well, sensational. We like to think people make way more money than they actually do. For fun, let's take a look at the NBA's biggest baller, Steph Curry. He pulled
Okay, that's sufficient for our class. So if you are interested, you may watch the rest of the video. So let's come back to our class. Come back to this question. Okay. So after watching that video, do you guys have any idea how to do question B? Any brave person? Okay, so let me call somebody's name. Just invite somebody to share their opinion. Hi, Elizabeth. Elizabeth, hello. Okay, I see your type. You may not want to speak. I understand. So, do you want to explain why you think it is non-symmetric? Okay, that's fine. You may not want to be speaking, or you may have some technical issue. No worry. So, anybody want to voice their opinion on this one? Salaries of NBA players. Okay. So all the answer is hidden in one of the histogram you see in the video. Do you guys remember there's a histogram in that video talking about the salary of NBA players like this? Do you guys remember there's such a graph in the video?
Yeah.
There's somebody like James LeBron, like Steffi, which is here, making extremely high salary. It was also very funny. I noticed somebody, just one person, one NBA player in that video, only make like a 50K a year. Do you guys notice that guy? It's a small detail. It's okay if you didn't notice. In that video, there's literally somebody who's making only 50K, like like your high school teacher. Even though they are playing the NBA, they only make like your high school teacher. So that's a huge difference. Somebody make like a 10, 40 millions. Somebody make like 50K. So referring to this distribution, we obviously observe that this is not symmetric. This is just so skewed. You will learn on the next page what is the skew mean. So this is non-symmetric because just not symmetric. Some people making crazy amount, some people making a high school salary. High school teacher salary, okay. So how about ice cream sales? Anybody want to voice opinion? How does the ice cream sales look like?
Symmetric.
I would agree with you, but why do you think so?
I feel like the price, I mean, it varies with ice cream, but probably not as drastic as it does for NBA players.
This is talking about sales. This is not talking about price. So sales means if you buy one ice cream, it is one ice cream. Two ice cream is two ice creams. not talking about whether it is expensive or not. Okay. Anyway, thank you for sharing. So first of all, this is symmetric. Second, the reason behind it is that imagine the x-axis is time, okay? The y-axis is sales. Most people eat most ice cream when the temperature is hot, right? Obviously, you can argue with me. You like to eat ice cream in the winter. I know. Some of you like that. But in general, most ice cream sells when it was hot in the summer, right? So as you can see, we started from the year when the new year arrived. It is still cold outside. Ice cream sales is low, but it is getting hotter and hotter. Somewhere around June or July, in a hot day, you will walk in a park, but you see a small van selling ice cream. You cannot hold yourself. You just go there, throw $5 into the van and grab the ice cream and run away. So that happens here, okay? Somewhere in June or July. However, August, you start feeling a little bit colder. September, you want to go to Aspen to see the fall leaves. October, wow, you are surprised. Why do not we have snowfall in Denver? As the weather getting colder and colder, you become less and less want to eat ice cream. So the ice cream sales actually peak in the summer, decrease as the temperature drops. Again, this is my reasoning. You may argue with me. So in this class, we just assume things that goes so ideally, so easily, okay? Anyone has any question about this? Why it is symmetric? Okay, so let's go to the next page. So we learn symmetry. Then we come to the next concept, skewness. On the previous page, we learned some simple graph, which is symmetric. Symmetric is the left part is the same with the right part. However, the skewness, it just tells us if somebody is not symmetric, what kind of shape it is. If it is left skewed, the value is more spread out on the left side of the mode. So this is left skewed. So the value is more spread on the left side of the mode. If it is right skewed, the values are more spread out on the right side of the mode. So right side of the mode, also called the right side of the peak. So first find peak, then find where the other values are. Okay, to the right or to the left. If to the left, left skewed. If it is to the stretch to the right, then it's right skewed. That's it. That's just the idea. So, and the last graph is symmetric. We have nothing to talk about it. So it's just very simple. Okay, so let's look at example 4. Among professional actors, so in your eyes, professional actors, they are very similar with the NBA players. Some people like Jennifer Aniston, like, what is your favorite actor? Tom Cruise. Who else have a different name? Favorite actor? Hi, Dasha. Are you there? Yes. What is your favorite actor? Just curious. Okay. I'm sorry, we cannot hear you. So,
Sorry, I said David Tennant.
oh, David Taylor.
Yeah.
Great, thank you. So is David Taylor a very popular actor? Very popular among people here?
Yes.
Great, thank you. Thank you. I finished all my questions. So some people like Jennifer Aniston or David Taylor, they are super popular. Millions of people like them. So they get really paid really well. However, some actors, they just went to a performing school, graduate from there. They make some YouTube videos, maybe get 10 or 20 views, just a little bit more views than the recording of this class. Those people make really little money. A small number make much more than the others. This is just true. Some people, only a small number of actors making so much money. All other people who try to be actors just not well paid. The distribution of actor salaries is therefore what? Is it symmetric? Is it symmetric? Anybody has any opinion? Okay, so let's draw a graph to help us understand what will happen. So the x-axis is how much salary. The y-axis is number of people, number of actors which can be paid as that kind of salary. I tell you, most people, most actors, they stay in the bottom of the society. They get like only 20 or 30 views for the YouTube video. However, somebody like Jennifer Aniston, let's say here is like 100 million. Jennifer Aniston, David Taylor, they get a salary like here. But we only have like a single digits of those top actors. Most actors just making like 50K per year, okay? So most of them like 50K. Somebody make 100K, 200K, but as the salary grows, less and less people making that amount. And until we see Jennifer Aniston, David Taylor, they're here. So the distribution of the salary of actors should look like this. First, when we read this graph, we conclude it is not symmetric, just like the NBA players. Second, is it left skewed or right skewed? So we compare, if we are unclear which one to choose, we compare with the graph. Compare this with the two left skewed and right skewed graphs. Which one does it more similar with this? Okay, anybody want to voice opinion? Thank you, Alejandro. I see. Great. Yes, it is right skewed. Just compare the shape. We don't need any math. We see this is more similar with this one. If you really need math, let me tell you this. Because we have one peak or one mode, right? One mode here. And there are some people making extremely high values. In statistics, we call it outliers. Just somebody who goes against group so much, stay away from the majority of people so much, like Jennifer Aniston, David Taylor. They're here. They make so much more than those just so actors. Outliers are at high values. That's why you see it is right skewed. If right outliers is on the right side of the mode or the peak, it is right skewed. If it is on the left side, it's left skewed. That's it. So it is right skewed with outliers at high values. Okay. Anyone has any question? Okay. So here we have a formal definition of outlier. It's almost saying the same thing with what I said. An outlier in the dataset is a data value that is much higher or much lower than most all other values. Jennifer Aniston makes so much more than most other actors' salary. An outlier can change the mean of data, but in the general do not affect the median or mode. So the mean we have not talked about it yet. The mean is just everything taking the average, right? Median, just the middle value of it. Middle value. We will talk about it on the next page. So let's go to the next page. Next page, we have the definition of mean and model. Eventually, this math class, in this math class, we need to do some calculation. Don't worry, the calculation is pretty easy. Just calculate mean. So what does mean mean? Mean is just you sum all the values divided by the total number of values. Maybe you have 10 people. Everybody reported their salary to you. You just add all the salaries together, divided by 10, because we have 10 values. This is the definition of mean. What's the definition of median? Median is different. Median is the middle value. Middle value. So let's say you have 10 people. Everybody reported their salary to you. Then you count from the lowest to the highest. There's somebody who is between the 5th and 6th of the 10 people. So that's the median, or the halfway between the two middle values. You start with the first people, then you go to the 10th people. There's some people are omitted. Just the middle guy. Okay, just this middle guy. Or the average of those two middle guys, if you have two middle guys. Does anyone has any question about the definition of mean and median? Okay. Mode. The definition of mode is the most common value in the distribution. So what does that mean? So let's say you have 10 people in the class. We have, let's say 3 people reported to you, they're making 50K per year. All other people are making different amount of value. Somebody make 100K, somebody make 20K. But those people who make the most common value, 50K, we have 3 people making the 50K. So which makes 50K is the most common value. And in other words, 50K is the mode of this group. I see Frank's comment in the chat session. And it sounds to me very interesting, your comment, because you said the more mode means the most. So this sounds like a little bit tongue twister to me. And we're also talking about mean. I understand your mean is different from the mean here. Okay, just interesting. So next example. When we finish the definition here, I would give you like a let's say 2 minutes to work on it. 2 minutes, just calculate the mean, median, mode. I believe that for median, for mode, you don't need to calculate it. You can just eyeball it, count it, which one is the median, which one is the mode. Obviously, you have to re-rank the order. Or the order, it has been ordered already, so it's easy. 2 minutes to work on example 5. Okay, so let's come back together. So the mean, you just add all the values you have, divide by how many students you have, right? How about the meaning and the mode? Okay, if you are unsure with anything, just go back to the definition. Median is a middle value in the assorted data set, and this has been assorted already. So we have 9. The middle one is the 5th one. 5th one is this guy. Mode is the most common value. Just look at it. Which value is the most common? 75, right? So 75. Does anyone figure out what is mean here? Feel free to speak out or type in the chat session. Thank you, Queen. So the mean is 81.9. The mean and the median, they're similar. They are different, but they are similar. The mode is a very different concept. It can be very far from the median and the mean. Okay, that's it for this question. Does anyone has any question on this one? Okay, so then we have a table talking about the properties of the 3 values we learned. I would just recommend you to read it by yourself when this class is over. Do not worry if you cannot memorize any of it. I just want to remind you the most important information is here. Okay, so this column is the most important information. It talks about which one is better in what kind of situation. For example, mode is most appropriate for qualitative. By saying qualitative, I mean those data with just a few categories. For example, when you divide people into different genders, in general, you divide people into male and female, right? Those are qualitative data. Also, you can record people's education, high school, college, graduate school. Those are also qualitative because we have a few categories to divide people into. The first one is most commonly understood, the mean. So there's nothing very special when you talk about. The second one is when there are outliers, we can use a median to represent the population, the average of the mean, average than the mean. So the keyword is when you have outliers. Okay, so that's the 3 different scenarios which you use. So for example 6, I'm not going to do it in class. I would recommend you to read this table and think about example 6. Okay. If we have time at the beginning of the class, next class, we may have a small discussion about example 6. So just think about it. Think about those values, those data you may have. And do not copy my answer. I write down my answer already. However, you need to look at this table and think about this ABC. It should be easy. Do not overthink about it. Okay, I think that's it for today's class. Okay, do not go. I need to take attendance. And remember to read example 6 when you go home. Okay, that's it for today's class. public timing 6:15. Stay here if you have any question. Otherwise, feel free to go.
Bye, everyone.
Bye.
Good weekend.
See you next week.
Yeah, I'm just letting you know that I've resubmitted project 4C.
Okay, great. Thank you.
Okay, bye.
Okay, thank you. Bye.